Thanks for joining this class, champions. In this class, I'll be teaching you mensuration of solid shapes. A solid figure or solid figures are three-dimensional in nature, and they have considerable length and they have considerable width as well. Some examples of solid figures include the cubeboard, which is three-dimensional in nature. You also have the cube, which is also three-dimensional in nature. You have other examples include the cylinder. You have the cone, which is also three-dimensional in nature and so is a solid shape. You have as well prisms. Prisms are solid shapes or solid figures, and you have the pyramid. In this class, I will be teaching you how to find the surface area and the volumes of these solid shapes. The first one I will be teaching you is the cubeboard. And to find the surface area of a cubeboard, you use the formula 2 times the length times the width, and 2 times the length times the height, as well as 2 times the height times the width of the cubeboard. And let's take an example to demonstrate how to find the surface area of a cubeboard. You are told to find the total surface area of the diagram below. Of course, a careful look at the diagram, you will observe that it is a cubeboard. So we are going to substitute the parameters given in the question into the formula for the total surface area of a cubeboard. And so you are going to have 12 times 5 plus 5 times 4 plus 4 times 12, giving you 60 plus 20 plus 48, which will be equal to 128. To find the total surface area, you will multiply that answer by 2, which is 256 centimeters square. The next thing I'll be teaching you is how to find the volume of a cubeboard. The volume of a cubeboard is the length times the breadth times the height of the cubeboard. Let's take this example. Find the volume of the cubeboard on the screen. To find the volume of this cubeboard, you are going to substitute the parameters given into the formula for the volume of a cubeboard, which is the length times the breadth times the height. And so you are going to have the volume of the cubeboard being equal to 4 times 5 times 8, which is equal to 160 centimeter cube. The next shape we'll be considering is the cube. The cube is in many regards similar to the cubeboard, except that all the sides are equal. The surface area of a cube is equal to 6 times the length of any side squared, which is 6s squared, where s is the length of the side of the cube, while the volume of a cubeboard is multiplication of the 3 sides of a cube, which is s cube. Let's take this example. Find the volume and the surface area of a cube whose side length is 4 centimeter. And so to find the volume of this cube, we'll substitute the length 4 centimeter into the formula for the volume of a cube, which is s cube. And so 4 cube will give you 64 centimeter cube. To find the surface area, we'll also substitute into the formula, which is 6s squared. So you are going to have 6 times 4 squared, making 16 times 6, which will give you 96 centimeter squared. So the next shape I'll be teaching you, the next solid figure, is the prism. The prism is a three-dimensional solid figure with uniform cross-section and depth. There are many types of prism that you can find, but I'll be teaching you just a type of prism just to demonstrate how to find the volume of a prism. But generally, the volume of a prism is the area of the cross section times the depth of the prism. The cross section is usually a shape, a solid shape that we know. So you just multiply it by the depth. Let's take this example. Find the volume of the figure that the prism that you see on the screen. It is a prism because it has a cross section, a uniform cross section, and it has a depth. So to find the volume of this prism, we'll first of all find the area of the rectangle of the cross section, which is, we'll divide the rectangle into two parts. You have the part A and the part B. The area of the rectangle A will be equal to 7 times 4, which is equal to 28 centimeters squared. And similarly, we also find the area of the part B, which is 6 times 5, giving you 30 centimeter squared. I haven't gotten the area of the two parts of the rectangle. We subsequently add these two areas together to get the area of the cross section. So the cross sectional area of the prism now will be equal to 30 plus 28, which is equal to 58 centimeter squared. So the volume of this prism will be the area of the cross section times the depth of the prism, which will be equal to 58 times 12, which is equal to 696 centimeter cube. The next shape we'll be looking at is the pyramid. We all know about the Egyptian pyramid. It's an example of a pyramid. The volume of a pyramid is 1/3 times the base area times the height of the pyramid. The base area can be rectangular, it can be triangular, or it can be a square base pyramid. But I will just teach you the volume of a square base pyramid. The volume of a square base pyramid is equal to 1/3 times the base area, which is b squared, times the height of the pyramid. Let's take this example. You are told to find the volume of the square base pyramid shown on the screen that has the length of the base is 5 centimeter and it has a height of 6 centimeter. So substituting these into the formula for the volume of a square base pyramid, you are going to have 1/3 b square h, which is 1/3 25 square times 6, which is equal to 50. The next shape I'll be teaching you is a cylinder. A cylinder has several parts, which is the radius, the height, and the base of the cylinder. To find the total surface area of a cylinder, when you cut the cylinder open, it is going to form a rectangle and two circles. The two circles will be at the top and the bottom of the cylinder. So the total surface area of this cylinder, will be the area of the two circles, which is at the top and the bottom, and the area of the rectangle, which forms the curved surface of the cylinder. And so let's derive the formula for the total surface area of a cylinder. The total surface area of the cylinder will be pi r square plus pi r square, which is the area of the top circle and the bottom circle, times 2 pi r, which takes the length of the rectangle times the height of the rectangle. So the total surface area of a cylinder will be 2 pi r square plus 2 pi r h. To find the curved surface area, the curved surface area will be the area of the rectangle, which forms the curved surface. And so when you remove the two circles from the area of the two circles from the formula for the total surface area of a cylinder, you get the curved surface area of a cylinder. So the curved surface area of the cylinder, as I've said, will be the area of the rectangle, which is 2 pi r, which forms the length, times the height of the rectangle. So the curved surface area of a cylinder will be 2 pi r h. So let's take an example to illustrate this. Calculate the surface area of a hollow cylinder which is closed at one end. If the base radius of the cylinder is 14 cm and the height of the cylinder is 20 cm, taking pi as 22/7. I've illustrated this on the diagram you can see on the screen. So the total surface area of the cylinder, as I've said before, is pi r square plus 2 pi r h. Because it is because the cylinder is hollow, that means you remove one of the circles. So it will be pi r square plus 2 pi r h. And when you substitute these parameters given in the question, you are going to have 616 plus 1760, which will give you 2376 centimeter square as the total surface area. Next is how to find the volume of a cylinder. The volume of a cylinder, you are told to find the volume of this cylinder on the screen. You will be given the diameter as 4 meters and the height of the cylinder as 15. The volume of a cylinder is pi r square h, and so we substitute those parameters into the formula, giving you 1320 degrees divided by 7, which is 188.57 meter cube. The next shape I'll be teaching you is the cone, and it's the final shape the last shape I'll be teaching you in this class. A cone has a slant height, it has the apex, which is the vertex, and it has a height and a base radius. The volume of a cone can be gotten using the formula 1/3 pi r square h. When you use this formula, you'll be able to get the volume of a cylinder. To get the total surface area of a cylinder, we must consider the sector of the circle from which the cone was formed. And so the total surface area of a cone will be pi r square, which is the area of the base of the cone, plus pi r h, which form the curved surface area of the cone. So take note of this. I will be applying it to solve questions. There exists a relationship between the sector of the circle and the cone, which is theta all over 360 being equal to the radius of the base of the cone all over the slant height of the cone. Also take note of this formula. So let's take this example. The radius and the slant height of a cone are 35 centimeter and 37 centimeter respectively. We are asked to find the curved surface area of the cone and the total surface area of the cone. So let's take the curved surface area first. The curved surface area of the cone, as I've said, is pi RL. So you just substitute the parameters and you get 4070 centimeter squared. And so to find the total surface area of the cylinder, you use the formula pi r bracket L plus R. Also substituting the parameters into this formula, you are going to have 100 times 72, which will give you 7920 centimeter square. That will be the total surface area of the cone. Let's take this example. A sector containing an angle of 120 degrees was cut off from a circle of radius 21 centimeter and folded to form a cone. You are asked to find the base radius of the cone. I gave you a formula earlier which relates the sector of a circle to the cone, and it is theta all over 360, which is equal to the radius of the base of the cone times the slant height of the cone. The radius of the sector of the circle from which the cone was formed is equal to the slant height of the cone. So when you substitute into this formula, you are going to have arrow, or the radius of the base of the cone, being equal to 7 centimeter. Lastly, let's take a problem involving the volume of a cone. You are asked to find the volume of the cone, which is shown on the screen. And so the height of the cone is 18, while the radius is 8. So the volume of the cone will be equal to 1/3 pi r squared times the height of the cone. Substituting into the formula for the volume of a cone, you are going to have 25,344 divided by 21, which will give you 1206.85 centimeter cube as the volume of the cone. Thanks for watching this video. I'll see you next time. Bye bye.